An unexpected discovery made by the James Webb Telescope. City lights in space, located 7 trillion miles away from Earth. This remarkable finding has sparked curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, revealing unusual bright lights emanating from it. What could be the cause of these city lights on Proxima Centauri b? Could this indicate the presence of life beyond our planet? Join us as we delve into how the James Webb Telescope detected these extraordinary objects in space. For years now, scientists and humans at large have waited and researched to get a glimpse of life beyond our solar system. Any evidence perceived to back up this space fantasy has been welcomed with open arms over time. Recently, the scientific community received the shock of their life when solid evidence of life forms existing in space were observed by the James Webb Space Telescope. While scouting outer space and reporting vital information back to Earth, the James Webb Space Telescope noticed strange, city lights shining from the exoplanet, Proxima Centauri b. These lights were just as its name implied, lights looking like they lit up a distant city. The possibility of an alien city existing on the star has left scientists reeling in wonder. Every one of them is baffled, because it seems like this is the existence they've all been waiting for. If this turns out to be true as everyone thinks it is, it means that there are intelligent life forms organizing civilizations foreign to what humans know in outer space, and we're only just discovering it. Peering into the city lights that are located 7 trillion miles from the Earth, NASA engineers can't help but wonder how long these lights have shone in space, waiting for humans to grow the required technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima b exoplanet where the city lights were found as tricky. He said so because this star system nearest to us has varied heating patterns that aren't similar to other planets. The usual rocky planets are known to take in sunlight and emit infrared radiation. Not so for this exoplanet, as its infrared nature is quite different from that of its host star named Proxima Centauri. This makes for a good observation by the James Webb Space Telescope, JWST, and the telescope came in handy as the right tool for the job. The JWST is able to easily detect infrared wavelengths. The distinct heat signature of Proxima b will play a great role in discovering the universal secrets of its atmosphere. And that'll be done because of the latest technology of infrared imaging capabilities possessed by the JWST. Scientists plan on using the telescope to reveal the mysteries surrounding this planet at atmospheric components. They also aim to use the Webb telescope to assess the possibilities of residing in this exoplanet. James Webb Telescope has an infrared sensitivity that's poised to explore what happens at Proxima Centauri b's nighttime. Picking up the faintest rays of light in the cosmic darkness is usually a struggle for space telescopes, but not for the JWST, as it can pick out even the tiniest rays of light from space. It's the perfect instrument to verify if the rumors of city lights on Proxima b night's side are true or not. Every artificial illumination in the cosmos can be sensed by the telescope, as long as it falls within a frequency band that's 1,000 times narrower than the starlight. Proxima b has an interesting relationship between its stellar features and surface interactions. The day's side of the exoplanet contains many solar panels that harness the bubbling, radiant energy possessed by the star. Its spectra edge also reflects incoming light rays at the same time. When Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night periods similar to what we have on Earth, with the daytime getting high on solar heat and the evening experiencing coolness. The planet is known to have temperature fluctuations that are determined by its composition. For example, if there's no atmosphere in Proxima b, the difference between its day and night periods will be wide and far between. If there's no moderating influence of atmospheric gases and oceans, the temperature of the day side will be so hot like a black body and the night side will horribly drop into cold darkness. The degree of temperature variation is a good subject for astronomers to unravel a deeper understanding of Proxima's atmospheric composition. Having an unrivaled infrared imaging capability, the JWST can efficiently examine the planet's thermal emissions to provide insightful data about its atmospheric properties. Interestingly, The orbit of the James Webb Telescope around the Earth falls in alignment with Proxima B's orbital period, making complete observations of its day and night periods within 11.2 Earth days. Since it indeed has an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can accommodate life. Some good pointers in determining if there's life is the presence of gases like oxygen, water vapor, and methane. If these elements can be found on the planet, it means that it supports habitable conditions. The process of successfully determining this requires scientists to be meticulous enough as they capture and examine light rays that move through the planet's atmosphere. This is a very challenging task to undertake. Even if the JWST possesses great capabilities for characterizing planetary atmosphere, it has a different major objective. The telescope has been customized to only analyze the variations in water vapor, carbon dioxide, and methane concentration. When it comes to identifying bonded oxygen, which is a vital indicator of life, the JWST is limited in this area. Even at that, the telescope still has valid reasons to search for other elements on the planet, such as ozone, which gives away an accurate level of vitality in the atmosphere. It's also worth of note to mention that the James Webb Space Telescope doesn't have absolute capabilities, and it can only peer at a few of the closest, habitable worlds to Earth. Carrying out a thorough atmospheric investigation, astronomers are now tilting toward ground-based observatories, like the extremely large telescope fondly referred to as YELT. The YELT is a telescope that has been scheduled to start operating in 2028, and it's carefully positioned to gaze deeper into the atmospheric structure of faraway exoplanets. It'll produce data on these planets that'll offer comprehensive and vivid insight into their level of habitability. NASA scientists and everyone are happily waiting for the deployment of future space telescopes like these. Until then, however, the James Webb Space Telescope remains a vital tool in our quest to uncover the mysteries of distant exoplanets. Even with its current limitations, the Webb telescope has the potential to offer deep insights that will revolutionize our understanding of exoplanetary exploration now and in the future. Scientists have an objective for future space telescopes, and that is to reduce the amount of bright light coming from a planet's host star so that astronomers can better see the lights reflected from a planet itself. They plan to do this by using internal masks or gigantic external satellites that are shaped like an umbrella, similar to using your hand to block out rays of the sun to enable you to see an object clearer. Reducing the fierce brightness coming from the host star, future telescopes will be better positioned to study faint reflections of light coming from a distant exoplanet, allowing for vivid analysis of its atmosphere and likelihood of supporting life. Doing this comes with its own challenges, however. Scientists will have to differentiate between gases generated from life and those from geological processes, such as volcanic activity. Astronomers aren't giving up on understanding the characteristics of exoplanets, so they're more able to spot signs of life and distinguish them from false positives. The Webb telescope contains a preview of scientific advancements from the research of exoplanets, offering a sneak peek into the amazing discoveries we're yet to find. As we stretch our understanding and exploration of the cosmos farther and farther, we're better positioned to understand the intricate workings of the universe and our various roles in it. After searching through all the planets in space, scientists have yet to find anyone that hosts life. Despite decades of searching through space for signs of life, the quest for forms of life on other planets continues. Are we alone in the universe? For millions of years, throughout human civilizations, humans have always wondered whether they are the only ones in the universe. This is an age-old longing that still hasn't left us in this present time. Even now, scientists have the James Webb Telescope in outer space, trying to spot alien civilizations hidden amongst us while studying all kinds of planetary bodies for signs of life at the same time. A popular narrative has spread in recent times that some aliens are truly out there in the stars, just waiting for humans to find them. To provide an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called Search for Extraterrestrial Intelligence in 1984, known as the SETI Institute. It is a non-profit venture that plans to sift through cosmic signals to pick up only radio signals from space. The reason for focusing on radio signals is because of their ability to travel through long distances without getting scattered or absorbed like other types of radiation. Due to this characteristic, radio signals are more likely to be detected by the 42 radio telescopes that constitute the Stellar Allen Telescope Array found in the Cascade Mountains of California. Though the SETI Institute has religiously observed signs of these radio signals generated by alien life, there haven't been any such signals for over 30 years. Jill Tarter is enthusiastic that they'll have a positive result, as they want to use the tools of the 21st century to accelerate the search. In the words of Jill, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." All of that continued until recent reports from NASA implied that the James Webb Space Telescope spotted city lights from a planet close to the Earth. It is believed that these planet lights are from the planet Proxima b, which is located on the closest point. The star system that is nearer to us has variable heating patterns. That is the latest observation by the James Webb Space Telescope, which is understood that the heat patterns aren't the same as other planets. The rocky planets, like the name implied, it's part of it, and in Earth. In essence, it is who and of is another is more so it does that to we tell it if is no the an in has on it to is at me is for some of them the James Webb Space Telescope, JWST, humanity's most advanced observatory in space, has recently made a groundbreaking discovery that has captivated the scientific community and the public alike: evidence of complex organic molecules on an exoplanet located in the habitable zone of its star system. This exoplanet, known as Kepler 452b, orbits a star similar to our Sun and is approximately 1,400 light-years away from Earth. The detection of organic molecules on Kepler 452b is a significant milestone in the search for extraterrestrial life, suggesting that the conditions for life as we know it could exist beyond our solar system. Kepler 452b was first identified by NASA's Kepler Space Telescope in 2015 and has since been a target of interest for astronomers studying potentially habitable exoplanets. Its location within the habitable zone, where conditions may be favorable for liquid water to exist on its surface, makes it a prime candidate for further exploration. The JWST's powerful instruments, including its infrared spectrograph, have allowed scientists to analyze the exoplanet's atmosphere with unprecedented detail. The discovery of organic molecules, which are the building blocks of life on Earth, raises tantalizing questions about the possibility of life on Kepler 452b. While the presence of organic molecules does not confirm the existence of life itself, it does provide compelling evidence that the conditions necessary for life may be present on this distant world. Further observations and analyses by the JWST and future telescopes will be crucial in determining whether Kepler 452b could indeed harbor life. In addition to studying Kepler 452b, the JWST continues to revolutionize our understanding of the universe's origins, structure, and evolution. Its ability to observe distant galaxies, stars, and planetary systems in unprecedented detail has already led to numerous scientific discoveries. From unraveling the mysteries of dark matter and dark energy to studying the formation of galaxies and the birth of stars, the JWST is poised to expand our cosmic horizons like never before. As astronomers eagerly await further data from the JWST and other upcoming observatories, the discovery of organic molecules on Kepler 452b stands as a testament to humanity's quest to uncover the secrets of the cosmos and answer one of the most profound questions: are we alone in the universe? The search for extraterrestrial life continues to inspire and challenge scientists, pushing the boundaries of our knowledge and igniting our imaginations about what may await us among